Hi, my name is Kiran Baburaj. Today, we are deep diving into binary search tree insertion. In this video, we will walk through the process of inserting values into the binary search tree, step by step with clear visualization. We will be inserting the following values into the initially empty tree. Let's get started. We begin with an empty tree. There is nothing here. So our first step is to insert the root node. The first value we insert is 50. Since the tree is empty, this becomes the root node of our BST. Every BST starts with a single root node, and all subsequent nodes will be inserted based on their value relative to the root. Next, we insert 30. Since 30 is less than 50, it becomes the left child of the root node. In a BST, all values less than the current node go to the left, while values greater than the current node go to the right. Now we insert 70. Since 70 is greater than 50, it becomes the right child of the root node. This maintains the BST property, that is left child less than parent less than right child. Next we insert 20. We start at the root and compare 20 with 50. Since 20 is less than 50, we move to the left child, which is 30. Since 20 is less than 30, it becomes the left child of 30. Now we insert 40. We start the root and compare 40 with 50. Since 40 is less than 50, we move to the left child, which is 30. Since 40 is greater than 30, it becomes the right child of 30. Next we insert 60. We start at the root and compare 60 with 50. Since 60 is greater than 50, we move to the right child, which is 70. Since 60 is less than 70, it becomes the left child of 70. Finally, we insert 80. We start at the root and compare 80 with 50. Since 80 is greater than 50, we move to the right child, which is 70. Since 80 is greater than 70, it becomes the right child of 70. And here we have our final BST after inserting all the values. Now I will show you how to implement the binary search tree in Python. First we will define a node class. Each node in the BST holds a key, which is the value stored in the node, and references it to the left and right child. The constructor method initializes the node with key and sets the left and right child to none. Now let's add a method to insert new keys into the tree. The insert method, it takes key as the input and places it in the correct position in the tree. If the new key is less than current node's key, we check if the left child is none. If it is, we create a new node there. If not, we recursively call the insert on the left child. The same logic applies to the right side if the key is greater or equal. And that's it. We have just implemented a basic binary search tree in Python. Finally, let's recap the key properties of a BST. All left subtree nodes less than parent node. All right subtree nodes greater than parent nodes. Average time complexity is in order of log n. The worst case time complexity is order of n. BSTs are incredibly efficient for search, insertion, and deletion operations, especially when balanced. They are widely used in databases, file systems, and more. Thanks for watching. Don't forget to like, subscribe, and hit the bell icon for more content on data structures and algorithms. See you in the next video. Happy coding. Thank you.